The most important aspect of sound deals with frequency information. A single frequency is a sinusoidal wave. Sound is a combination of many such waves, each with its own amplitude and phase. Audio frequencies are from 20 Hz to 20 kHz. There will be a distribution of both amplitude and phase. The former is shown in a spectrograph and the latter is shown in a phase diagram. Usually we show the amplitude distribution. We will show the amplitude distribution in time for the sound created in the last tutorial. I have written an application in Kiwi Python which I describe in the link in the description. These are the three values or parameters that can be changed. The three parameters are phase, frequency and number of periods. Changing the phase changes the initial phase of the sine wave. Immediately after changing the phase via the buttons, two lines will update on the unit circle. The green line is the radius line at that phase angle. The red line indicates the length of the y component. The frequency parameter is the frequency. In the program, we only allow frequencies to be 0.1 Hz to 1 Hz in steps of 0.1 Hz. The reason we have these low frequency is so that the sine curve is drawn in real time. For audio waves, we can just scale the graph in time. The third parameter that we may vary is period. This stands for the number of periods that the sine curve will be displayed over. This will be a number from 1 to 10. Depending on the last two parameters, we can find the final time displayed on the right corner of the rectangular region where the sine curve is drawn. For the case we have a frequency of 0.1 Hz. Each 360-degree revolution is 10 seconds. Thus, if we only display one period, this is the final time. For the case frequency is 0.2 Hz, each complete revolution or period is 5 seconds. If we display two complete periods, PER is 2. The final time is again 10 seconds. In this program, we have only dealt with very small frequencies. If the frequency is, for example, 1000 times greater, the time period will be divided by 1000. We have seen that the 0.1 Hz wave has a time period of 10 seconds. Thus 100 Hz wave has a time period of 10 milliseconds or 0.01 seconds. Even though degrees are mostly used to describe angles, radians are the natural units for angles. A radian is about 57 degrees or 180 divided by pi. The amplitude distribution of the frequencies in time for the sound created in the last tutorial can be found from the spectrogram view in Audacity. You can see that there are about 10 components.